Welcome to today's section. Today we are going to study about chemical equilibrium. Equilibrium that arises from two words, Latin words libra and equal. Libra means weight and equal means balance. So equilibrium arises from two Latin words. Libra means weight and equal means balance. So we'll study the characteristics of chemical equilibrium. Chemical equilibrium can be attained only in reversible chemical reactions. First characteristic is chemical equilibrium can be attained only in reversible chemical reaction. There are two types of chemical reaction, reversible and irreversible reaction. Reversible reaction means reactants are converted into products and at the same time products are converted into reactants. So all reversible reactions are represented by these type of arrows. An example for reversible reaction is nitrogen gas combines with hydrogen gas produces ammonia. This is an example for a reversible reaction. Second condition, equilibrium can be attained only in closed system. In thermodynamics, we learned about the type of system, that is open system, closed system and isolated system. Open system can exchange both matter and energy with the surroundings. Closed system can be exchange only energy and insulated system cannot be exchanged both matter and energy. So chemical equilibrium can be attained only in closed system. Third property. All the measurable properties like pressure, the macroscopic property pressure, volume, temperature, mass, etc., concentration, etc., will be a constant at the chemical equilibrium. Once again I will say, all measurable properties of the system like pressure, volume, temperature, mass, concentration, etc., will be a constant for a chemical equilibrium. So chemical equilibrium is a state of a system at which all measurable properties will remain constant. Once again I will say, chemical equilibrium is a state of a system in which all the measurable properties, pressure, volume, temperature, mass, concentration, etc., will be a constant. So once again I will say, characteristics of chemical equilibrium. Chemical equilibrium can be obtained only in reversible reaction. So we are considering only reversible reaction. Second, it can be attained only in closed type of system. Then at equilibrium, all the measurable properties will be a constant. So we can define a chemical equilibrium is, it is a state of a system at which all the measurable properties will be a constant. Okay. Next we will study about law of chemical equilibrium. Before stating the law, we will derive a mathematical expression for law of chemical equilibrium. After that I will state the law. So we consider a general reaction. For example, A moles of A react with B moles of B. This is reversible, gives C moles of C and D moles of D. Let all are in gaseous state. Here A, small a, B, C and D are called stoichiometric coefficients. Stoichiometric coefficients are the numbers which are used for balancing a chemical reaction. Stoichiometric coefficients are the numbers which are used to balance a chemical reaction. So this is an example for, or is a general example for a reversible chemical reaction. Here there are two types of reaction. That is reactants. These are called reactant and these are called the product. Reactants are converted into products and products are converted into reactants. So first type of reaction, that is taking place in that direction, is called the forward reaction. That is, forward reaction is conversion of reactants into products. Second, backward reaction. What is that? Conversion of products into reactants. So in a reversible reaction, there are two processes takes place. One is forward reaction and second one is backward reaction. After some time, when a reaction reaches in an equilibrium, the speed of forward reaction and backward reaction become equal. That stage is called the equilibrium. So here we are not using the word speed. Instead of speed in chemistry we are using rate. Rate means speed of chemical reaction. So there are two types of reactions, forward reaction and backward reaction. After some time the rate of forward reaction becomes equal to backward reaction. Then that state is called the equilibrium. So we derive a relation for law of chemical equilibrium. So according to law of mass action, we already learned this law, or it is also called rate law. According to law of mass action, the rate of a chemical reaction will be directly proportional to the concentration of its reactants. So this is forward reaction. Here reactants are A and B. So according to law of mass action, rate of forward reaction, you can represent it using RF. If you are difficult to write this R, you can write this. RF. Rate of forward reaction will be directly proportional to concentration of reactants. Here reactants are A and B. So concentration is represented by square bracket. This is read as concentration of A. Then we have to write this stoichiometric coefficient as the power of the concentration T. Then there are two reactants, so we have to take the product. Concentration of A raised to A into concentration of B raised to B. This is the law of mass action for this forward reaction. We can replace this proportionality. Rate of forward reaction is equal to Kf, where Kf is a proportionality constant for forward reaction. Kf into A raised to A into B raised to B. Let it be equation 1. Then can apply this law of mass action to backward reaction. Just look from this direction. That is C and D is converted into A and B. Here the reactants are C and D for backward reaction. So rate of backward reaction is directly proportional to, can you say? Yes. Concentration of C raised to C into concentration of D raised to D, because here the reactants are C and D. C moles of C, D moles of C. So we are taking the stoichiometric coefficients as the power. Same way we can replace this proportionality by, we can give Kb. Kb into C raised to C into D raised to D. Let be equation 2. Is it clear this much? So There are two types of reaction, forward reaction and a backward reaction. According to law of mass action, I will state the law. The rate of a reaction will be directly proportional to the concentration of reactants. That is, reactants concentration increases, rate will also increases. So when we apply this for forward reaction, we will get this expression, and for backward reaction, we will get the expression. Then we know that, can I wrap this? At equilibrium, the rate of forward reaction will be equal to rate of backward reaction. So we can, this left hand side both are equal, so we can equate the right hand side. So RF is equal to Kf into A raised to A into B raised to B is equal to RB, yes, Kb into C raised to C into D raised to D. Let me rub this too. So we will take the constants at the same side and concentration to the other side. So we'll get here Kf, then Kb will be down, Kb will be is equal to here C raised to C into D raised to D divided by A raised to A into B raised to B. These two are constants, so we can replace this value by another constant. A constant divided by another constant will get a constant. That is called capital K. So capital K is equal to C raised to C, D raised to D divided by A raised to A raised to A into B raised to B. This is the mathematical expression for law of chemical equilibrium, where K is called equilibrium constant. Where K is called the equilibrium. So we will state the law. Can you say? The equilibrium constant of a chemical reaction will be equal to ratio of concentration of products to concentration of reactants, with each term raised to the power which is equal to the stoichiometric coefficient in a balanced chemical reaction. Once again, I will state the law. Law of chemical equilibrium is stated as equilibrium constant is equal to the ratio of concentration of products to concentration of reactants, with each term raised to a power which is equal to stoichiometric coefficient in a balanced chemical reaction. So this is the law of chemical equilibrium, and this is an equation for calculating equilibrium constant for a chemical reaction. Clear? So we'll write using an example. So write the question. Express the equilibrium constant for the following reaction. Write the reaction into gas plus 3H2 gas reversible 2NH3 gas. So you have to write the equilibrium constant for this reaction. Okay, we will write capital K is equal to products concentration. Here only one product. What is that? NH3. NH3. Then the stoichiometric coefficient. Here how many moles of ammonia is there? 2. So here the stoichiometric coefficient is 2. Here only one product, so there is no need to write another one. Divided by reactants. Here there are two reactants. What are they? Nitrogen. How many moles? 1 mole. So no need to write. And hydrogen. How many moles? 3. So this is the equilibrium constant for this reaction. So write one more example. Write the equilibrium constant for hydrogen combines with iodine gives 2Hi. Can you write? Yes, try. Yes, K is equal to Hi. That is a product. Only one product. Hi square divided by H2 into I2. So these are the basic idea about chemical equilibrium. Is it clear? Okay. That's all for today's section. We'll continue with next.